This is Lesson 5.3, Solving Systems by Elimination. Quick reminder before we get going here. Many times as you solve these problems, you'll have to ask yourself a question like this. 3x times something is going to be negative 12x. In this case, just take the negative 12 divided by 3. Ask yourself, what is that? Negative 4. So that's going to be the number that you'll need to use. Second of all, well, before we get into the vocab, reminder, the lesson is that you're going to be adding equations instead of substituting or graphing so that you eliminate. You'll be either eliminating either the x or the y variable. Will just disappear when you add the equations together. All right, one new important vocab word, coefficient. Coefficient is the multiplier of the variable. Okay, we'll see this in the first example. The directions will say something like solve the system. Again, we have two equations. In this case, we see coefficients of 3, 2, negative 2, and 3. Always keep in mind that that minus sign can be treated as a negative 2. All right. Again, looking back at our directions, we see that we are going to add the equations so that something cancels. In this case, hopefully you can see that the y variable in this case will cancel and disappear. 3 plus 3, we get 6x. 4 plus 8, we get 12. Again, the y's disappeared. Woohoo. So, if 6x equals 12, x equals 2. We have half our solution, and we've done most of the work in the problem. Now we have to go back and figure out the y variable. In this case, take the x variable, and you can go to either equation here. I think I'm going to choose the top equation to plug the 2 into because there is no minus sign there. So 3 times 2 plus 2y equals 4. So 6 plus 2y is 4. Subtracting 6 from both sides. 2y equals negative 2. And then dividing by 2. We can see that y equals negative 1. So our second part of the answer is negative 1. So here is our solution to the problem, 2, negative 1. Example 2. A little bit more complex. You can see that the coefficients in this case are bigger. You can also see that adding these up doesn't gain us anything. That is, we're going to get a 14x and a negative 16y. Nothing disappeared when we add them up. So in this case, what we're going to do is we need to multiply one of the equations by a magic number. Hopefully you see that nothing times 3 is 11 and vice versa. Nothing times 11 is 3. But if you look at the 20 and the 4, we certainly could take the second equation and multiply the whole equation by 5. And that would give us, in the y variable, a positive 20. All right, so take the first equation, just write it down as it is. Second of all, take that multiplier and multiply all the coefficients by 5. So we get a 15x, we get a 20y, and a 36. All right, now we see that our coefficients cancel, the y coefficients. Again, reminder that first coefficient is a negative 20, plus a positive 20 is 0. On the x's, we have 26x's is equal to 60 Whoops, I made a mistake. I forgot to multiply the 36 by 5. Let's fix that. 36 times 5. On my calculator, I see that that is 180. Okay. Phew. And so now when I add up 28 and 180, I get 208. Now we're going to divide through by 26. Again, grabbing the calculator, you can see that 208 divided by 26 is 8. We can check that over here to make sure that that is correct. 16.4, yep, 208, okay. Again, we have half my answer. Now I need to take that 8 and go back again to either equation. I think I'm going to take the 8 to that equation there. All right, so we have 3 times 8 plus 4y is equal to 36. So 24 plus 4y is 36. Subtracting 24 from both sides, we get 12. And dividing by 4, we get y to be 3. All right. So there we have it. There is our second system solved. In this case here, we had to multiply through by a magic number, 5. I almost forgot to multiply the 36 times the 5 there when I did that. Common mistake. And we get an x and a y. Most of the time you will get answers which are integers and not ratios too. That's another little tip that you may or may not have made a mistake. Again, you can always check your answers by taking the x and the y value back to the equations and plugging them in for both x and y. And it should give you a true statement.